So we're back and we're moving into section 10.2. This typically is covered over 2 days, but under the new schedule and hybrid, we're going to cover both days in one block period that we have. I've kind of minimized it to fit into a 70-minute window for us. So we have 2 more identities to work on today. So these are the sum and difference identities for the tangent function. They're a little more complicated to look at than the sum and difference for sine and cosine because of the big fraction here. But they're pretty basic. Both formulas are essentially the same. The major difference is the addition and subtraction operation in the numerator and denominator switch. Okay, so if it's a tangent of angle alpha plus angle beta, if it's a sum, then in the numerator we're going to have a sum, and then in the denominator we're going to have a difference. And if it's a tangent of alpha minus beta problem, then in the numerator it'll be a difference, and in the denominator down here it'll be a sum. So that's the main difference, really. The tricky part here is you're not always going to be presented a problem in this format, tangent of some angle plus another angle. It'll be the tangent of some random angle that's typically not a multiple of a special angle, and you have to decompose it into 2 angles that are multiples of special angles. That's typically the most complicated part here. So first example here is to evaluate the tangent of 195 degrees. Again, this is all without a calculator. So the hardest part is deconstructing 195 degrees into the sum or difference of 2 angles. You can usually do this quickly by either adding or subtracting the basic special angles, 30, 45, and 60 degrees, to find some pair that works. So in this case, I added 40 degrees to 195 and discovered that 240 minus 45 is 195. 240 is also a multiple of a special angle, multiple of both 30 and 60 degrees. So this is going to work out for us. So at this point here, we need to evaluate, we need to know what the tangent of 240 degrees is and the tangent of 45. And again, this is without a calculator. So over on the unit circle here, I sketched both a 45-degree angle here in green. 45 is a reference angle, so this one works out nicely for us. And then I also sketched this angle here in red, 240 degrees. From this 240-degree angle, I created my reference triangle here and discovered that I have a 60-degree reference angle. It's down here in the 3rd quadrant, so the horizontal and vertical measurements are both going to be negative. And it's a 30, 60, 90, so the long leg of a 30, 60, 90 is negative root 3 over 2. And the short leg is negative 1/2 here. So what we have to do now is calculate the tangent of this angle here. So tangent is opposite, negative root 3 over 2 over adjacent, negative 1/2, or y over x, depending on how you're looking at it. So my work for that is right here on the right. So negative root 3 over 2 divided by negative 1/2 is going to produce a positive value. I multiply by the reciprocal of the denominator, simplify my common factors here, and end up with a positive root 3 as the tangent of 240 degrees here. So that's tangent 240, and then for the tangent of 45 degrees, remember 45, 45, 90 triangle should always give us root 2 over 2's. So the vertical leg here is root 2 over 2, and the horizontal leg is root 2 over 2. When I take the tangent of that 45-degree angle here, it's y over x, or opposite over adjacent, and root 2 over 2 divided by root 2 over 2 is going to produce a value of 1. Now that we have the tangent of 240 and 45 degrees, we can move into working on our formula here. So we populate the formula. So this is a difference. So our formula is going to run tangent of 240 degrees minus tangent of 45 degrees, all divided by 1 plus tangent of 240 times tangent of 45. Again, notice that if it's a difference here, it's a difference in the numerator, and then an addition, a sum in the denominator there. Okay, so now we're going to drop our values in. So tangent of 240 degrees is root 3 over 2 minus, and then tangent of 45 degrees is 1, all over 1 plus tangent of 240 is root 3, tangent of 45 is 1, and then we're going to simplify this. It doesn't always simplify that nicely for us, but we'll do what we can. At this point right here, root 3 minus 1 you can't combine them any further, and then 1 plus root 3 times 1 becomes 1 plus root 3. We can't simplify this the way it is. However, we're not allowed to leave a radical in our denominator, so we're going to have to rationalize by using the conjugate of the denominator, which is 1 minus square root 3. And we're going to have to make sure we do this correctly. So we're going to multiply by 1 in the form of 1 minus root 3 over 1 minus root 3. This is a FOIL problem, right? So root 3 times 1, root 3 times negative root 3, negative 1 times 1, and then negative 1 times negative root 3. And then same process in your denominator here. So after we go ahead and FOIL, distribute, the numerator produces root 3 minus 1 plus root 3. And then in the denominator, remember when we multiply by conjugates in the denominator, the outer terms and the inner terms, the products of them, will always negate each other and produce a 0. So really in this problem, you just really multiplying the first terms, 1 times 1, and then the last terms, negative root 3 times negative root 3 produces a negative and then 3. So we're going to combine our like terms here. So this is going to leave us with 2 root 3 minus 4 over negative 2. And then we have common factors in the numerator and denominator, so we can simplify those, right? So again, don't just cross out the 2's. If you're going to simplify here, a factor of your denominator needs to also be a factor of all terms in your numerator here. So this is going to simplify to root 3 minus 2 over negative 1. And then we can clean this up a little bit and make it negative root 3 plus 2 here. So the tangent of 145 degrees, tangent of 195 degrees is negative root 3 plus 2 here. There are alternative ways to do this. So another way to look at it is if you had the tangent of 195 and decomposed it into the sum of 150 and 45 degrees. Same process, except you're working with a different angle here, 145 or 150, and it's a sum. So 150 degree angle runs right here, leaving us with a 30 degree reference angle, leaving us with a short leg of 1/2 and a long leg of negative root 3 over 2. Again, tangent of this angle right here, your reference angle, is going to be 1/2 over negative root 3 over 2. And you can simplify that right here. So 1/2 over negative root 3 over 2. We're going to multiply the numerator by the reciprocal of my denominator. And this leaves us with negative 1 over root 3, which should be rationalized to negative root 3 over 3. So the tangent of 150 is right here. We already calculated the tangent of 45 earlier, which was 1. So then when we populate our formula, it's a sum, so it's going to be tangent of 150 plus tangent of 45. And then in our denominator, it's going to be 1 minus tangent of 150, tangent of 45. So we're going to populate our formula here, negative root 3 over 3 plus 1. And then in my denominator, 1 minus negative root 3 over 3 times 1. Slow down, make sure you do your algebra correctly. In the numerator, I have to produce a common denominator when I add the 1. So I'm going to multiply, well, actually, in this case, what we're doing is we're going to just clear our fractions completely. So we can multiply the numerator of the whole fraction and the numerator of, the denominator of the whole fraction by by 3 here, and that'll remove all small denominators. right? So negative root 3 over 3 times 3 is going to be left with negative root 3. 1 times 3 is 3. And then in the denominator here, 3 times 1 is 3. And then 3 times root 3 over 3 is root 3. At this point, we're still going to have to rationalize our denominator. We have a radical down here. So the conjugate of the denominator is 3 minus root 3. So I'm going to multiply both numerator and denominator by this to rationalize. Again, it's FOIL in the numerator, and then in the denominator, it's still FOIL, but you're really only multiplying your first terms and your last terms because the outer and inner products here will always produce a 0. So foiling in the numerator leaves us with negative 3 root 3 plus 3 plus 9 minus 3 root 3. My denominator leaves us with a 6. We can combine some terms in the numerator here. So that'll leave us with negative 6 root 3 plus 12 over 6. And again, if you're going to simplify this big fraction, make sure you use a factor of the denominator that's shared among all terms in the numerator. And in that case, it's 6. So we're left with negative root 3 plus 2, which matches the answer above. We just used a different process there.